In the circular motion videos, we saw that an object moving at a constant linear speed will undergo uniform circular motion if it experiences an acceleration that is perpendicular to its direction of motion. We call this acceleration centripetal acceleration, which is directed towards the center of the circular path. We now know that this acceleration must be caused by some force in accordance with Newton's second law. This force is called centripetal force. This force is also directed towards the center of the circular path. Newton's second law defines the force being equal to the product of the mass and its acceleration. Since the acceleration is centripetal, then the force can be written in terms of the angular speed as well as the linear speed. There is another force involved in circular motion called centrifugal force. It should be noted that centrifugal force is not a real force, but is the result of Newton's first law of inertia. Recall that Newton's first law states that an object will want to stay in its current state of motion and resist any force acting upon it. As the object is moving with a constant linear speed, it will move in a straight line in the absence of the centripetal force. So the object will want to remain moving in a straight line due to its inertia. The centrifugal force is the object's natural tendency to resist the change in the direction caused by the centripetal force. So while centripetal force is directed towards the center, or is center-seeking, the centrifugal force is outward-seeking. It has the same magnitude as the centripetal force, but points in the opposite direction. We'll designate the centrifugal force with a symbol capital F with subscript C. Even though the centrifugal force is not a real force, its effect appears very real to the object moving in circular motion. Centrifugal force is the reason why you lean to the right when the car you're in is turning left. It's the reason why you have to hold on when you're on a fast-moving merry-go-round, and it is how excess water is removed from clothes in washing machines. The centrifugal force is the force that the object experiences. Consider the following example where you're riding a roller coaster at a theme park. At the point when you're on top of a loop, based on your own experience or what you know about forces, do you feel heavier or lighter or the same as if you're standing on flat ground? To answer the question, consider the forces acting on your body. First, you have the force of gravity, or your weight, pulling down on you. If you're moving in a circular orbit at the time, then you also experience centrifugal force pushing you outwards. At the top of the loop, this outward direction is straight up. If we take the downward direction to be positive, then Newton's second law gives us the net force in the vertical direction being equal to the weight minus the centrifugal force. Of course, the difference gives us the net force, resulting in a net acceleration. The weight is equal to mass times gravity, and centrifugal force is equal to the centripetal force, which is mass times the centripetal acceleration. We see that mass appears as a common factor in both sides of the equation, so we can cancel mass out. We're now left with just an equation for acceleration. So if gravity is greater than the centripetal acceleration, then the net acceleration is downwards and the person will stay on the coaster seat but with a reduced weight. But if the centripetal acceleration is greater than gravity, then the net acceleration is upwards and the person's tendency is to fly off the seat and be weightless. The centripetal acceleration is given by the square of the linear speed divided by the radius of curvature of the loop. For this example, the radius of the loop is 10 meters. So what is the magnitude of the centripetal acceleration required to make the rider weightless at the top of the loop? That is, the net acceleration experienced is 0. What is the minimum speed needed at the top of the loop to achieve this weightlessness? If the speed of the car was 15 meters per second at the top of the loop, what is the net acceleration experienced by the rider? In summary, The centripetal force is a force that causes an object moving at constant speed to move in uniform circular motion. It is equal to the mass multiplied by the centripetal acceleration, which is the square of the speed divided by the radius of the circular orbit. The mass has a natural reaction against the centripetal force, which is called the centrifugal force. The centrifugal force is equal to the magnitude of the centripetal force but points in the opposite direction. The centrifugal force is not a real force and does not exist if there is no circular motion.